Hello everyone. Hope you all are doing very good. Physics is never a difficult subject for a student who is interested, provided he or she has a clear and strong physics teacher. So here I am, Mr. Dharanidhar, your favorite physics teacher in your favorite YouTube channel, Bhautics. So today I have brought you one more question which was asked in the previous year board examination in the year 2022, and the question paper set number is 31/3/1, which was asked for 5 marks. This question has two parts. First part is here, second part also will solve soon in this video itself. So now the question goes like this. Draw a ray diagram to show the path of reflected light ray. He is asking us to draw the path of reflected light ray when incident light ray passes parallel to principal axis of a concave lens. So we have to draw first a concave lens. So how to draw? With measurements I will give you. Look at it. First take a straight line of length 12 centimeters. 12 centimeters straight line you take, and you mark the points at 6 centimeters also, and 9 centimeters also, and 3 centimeters also, right? So now you remove the scale. After removing the scale, this you name as optical center, this point you name as F2, and this point you name as 2F2. This point you name as F1, this point you name as 2F1. So now you take a compass and take the radius of compass as 5.8. See, 5.8 centimeters. You can see, observe neatly. You can observe neatly the radius is around 5.8 centimeters, right? So take 5.8 centimeters as radius, and with 2F2 as center, draw an arc, okay? And with 2F1 as center, draw another arc, okay? Like this. Draw a bit thicker arc. Here also with 2F2 as center, draw a bit thicker arc, right? So now close this arc like this. This gives us the concave lens. Erase the extra part so the diagram will look good. And it is important that you draw the line at the center here like this. Why do it is? Because this line represents the point where the light rays should change the direction. So first question is, light ray passes parallel to principal axis. Okay, so when light ray passes parallel to principal axis, this one will be the incident light ray. Until this line, the light ray should come straight. Exactly at this line, the light ray should change the direction. How the light ray should change the direction? As concave lens is a diverging lens, it should appear that passing through focus. So make this point and this point as coinciding on the scale like this, and then from focus to the point you should draw a dotted line, and from that point draw a thick line. This is how the reflected light ray will pass when incident light ray passes parallel to principal axis. Following the same procedure which I have mentioned below, I have constructed this lens and this diagram. So now second case is the incident light ray should be directed towards the principal focus. Then the reflected light ray will pass parallel to principal axis like this. Right. What is the next question? There is part B also in this question. The part B of this question is, a 4 centimeter tall object is placed perpendicular to principal axis of a concave lens of focal length 24 centimeters. The distance of the object from the lens is 16 centimeters. Find the position and size of the image. So according to the question, the position of the object will be at 16 centimeters from the optical center. Focal length of convex lens is 24 centimeters. Means the object is placed between optical center and focus. So now when in case of a convex lens, if the object is placed between optical center and focus, image will be formed on the same side of the lens. Virtual, erect and magnified image will be formed. So they ask to find the position and size of the image. Position of the image is also on the left side. So we should get V also as negative. Size of the image. Size of the image also we should get as positive. Then we did the problem as correct. So let us go ahead and solve the problem. Given data is u is equal to minus 16 centimeters. Focal length f is equal to plus 24 centimeters. Right. Because convex lens, right, focal length will be 24 centimeters. Right. So now we have to find out the image distance. Convex lens formula is 1 by f is equal to 1 by v minus 1 by u. So 1 by 24 is equal to 1 by v minus 1 by u is minus 16. So this becomes 1 by 24 is equal to 1 by v plus 1 by 16. Plus 1 by 16 goes that it becomes minus. So it will be 1 by v will be equal to 1 by 24 minus 1 by 16. So then we can take it as 1 by v is equal to 24 and 16. What will be the LCM? 24 and 16 LCM will be 48. 16 3 is 48, 24 2 is 48. 48. 24 2 is 16 3 is. So 1 by v is equal to 2 minus 3 minus 1 divided by 48. So from here we can write v is equal to minus 48 centimeters. We got v now. They also asked us to find size of the image. How will we find size of the image? From the magnification formula. We know magnification m is equal to v by u in lens. So magnification m will be equal to, that also will be equal to height of image divided by height of object. Correct. So v we got as minus 48 centimeters divided by u is minus 16 centimeters. That will be equal to height of image divided by height of object. Okay. Minus minus cancels. 16 1 ja, 16 3 ja. So 3 is equal to height of image divided by height of object. So we want height of image. So height of object in this side, it becomes 3 into height of object is equal to height of image. How much they gave height of object? Height of object is given as 4 centimeters. So 3 into 4 is equal to height of image. So which implies height of image is equal to plus 12 centimeters. So we got the two answers. What are the two answers they asked? They asked us to find the height of the image and the image position. After this, if we write the conclusion of the question as, we can write here as position of the image, position of the image is at 48 centimeter on same side of lens. And image is 12 centimeter of height. This is the conclusion statement which we need to write. Okay. Thank you. We'll meet in the next video.